The Horsehead Nebula, one of the most prominent and captivating components of the Orion molecular cloud complex, has been a subject of keen interest and investigation by astronomers for many years. This nebula is situated within the Orion constellation and lies at a distance of 1,344 plus 20 light-years. The Horsehead Nebula is replete with bright stars and dense gas clouds, visible only through optical observation. Located at the center of the Horsehead Nebula is M42, classified as an emission nebula known as an H2 region. This nebula serves as one of the most prominent pieces of evidence for the birth of stars. Its gas and dust enrich the interstellar environment during the process of star birth. Particularly, the bright stars within it influence the dynamics of star formation. These luminous stars compress the surrounding gas and dust clouds through intense radiation pressure and winds generated by young stars, leading to the collapse of the molecular clouds surrounding the stars. The star formation within the Horsehead Nebula acts as a laboratory for astronomers to understand the process of stellar birth. Stars emerge as a result of the gravitational collapse of dense gas and dust clouds within the nebula. This process is crucial for understanding the evolution of stars from birth to death. Additionally, studying various phenomena arising from the process of star formation allows astronomers to gain a deeper understanding of how the universe takes shape. The Hubble Space Telescope and other advanced observatories provide valuable tools for examining the internal structure of the Horsehead Nebula. These observations reveal star formation regions within the nebula, complex interactions of gas and dust, and the disks surrounding stars in greater detail. This enhances our knowledge of the nature of the universe and allows for a better understanding of the processes of star formation. The discovery and study of the Horsehead Nebula contribute valuable insights to humanity's endless quest to unravel the mysteries of astronomy and the universe. The Horsehead Nebula, a large cloud of gas and dust that is approximately 24 light-years in diameter, is part of the Orion molecular cloud complex. Within the nebula, the temperature of the gas typically ranges from 10 to 20 Kelvin, while the density of the dust is generally around 10^-6 particles or cm^3. This nebula contains various chemical species such as molecular hydrogen, H2, atomic hydrogen, H, molecular oxygen, O2, molecular carbon monoxide, CO, and other molecular components, all of which play significant roles in the processes of star formation. In particular, one of the bright stars within the Horsehead Nebula, Theta 1 Orionis C, is an important factor influencing the behavior of gas and dust within the nebula. This star is a giant star with a spectral type of O6 and a surface temperature of approximately 40,000 Kelvin. Theta 1 Orionis C affects the interstellar environment around it with intense radiation pressure and stellar winds. These interactions can lead to the compression of surrounding gas and dust clouds and the collapse of regions of star formation. The potential for the James Webb Space Telescope to examine the Horsehead Nebula represents an exciting milestone in space observations. With its 6.5-meter primary mirror, the telescope enables observations with exceptional sensitivity in the infrared region. This will allow for a more detailed examination of the internal structure of the nebula and provide deep insights into the processes of star formation. Additionally, the James Webb Space Telescope will have the capability to observe significantly broader wavelengths than previous space telescopes, enabling a more detailed examination of the types and distribution of gas and dust within the nebula. These new observations will enable us to understand the complexity of the processes of star formation and test theories about the evolution of the universe. Furthermore, comparing the process of star formation in the Horsehead Nebula with other star-forming regions within the galaxy could provide a more comprehensive understanding of the general processes of star formation in the universe. These observations could represent a new milestone in astronomy and help us better understand the mysteries of the universe. The Horsehead Nebula, with its dazzling appearance, stands out as one of the most prominent structures in the night sky, situated within the Orion constellation. This nebula serves as a laboratory for studying the processes of star formation and is a subject of great interest for astronomers. Exploring the Horsehead Nebula provides a valuable opportunity to understand the birth and evolution of stars. The gas and dust clouds within the nebula are key components of the process of star formation. These materials come together under the influence of gravity, condensing to give rise to the birth of new stars. This process begins with the gravitational collapse and condensation of gas clouds within the molecular nebula. In regions of high density, the gas and dust material reaches sufficient pressure and temperature for nuclear fusion to commence, triggering the birth of stars. The star formation regions within the Horsehead Nebula, particularly rich in young stars, are dense with gas and dust clouds. These regions harbor gas and dust disks around stars, providing material for the formation of planets and other celestial bodies around young stars. Additionally, these regions are observed to have high density in radio, infrared, and microwave wavelengths. The brightness of the Horsehead Nebula is illuminated by a hot and bright star nearby, often referred to as Theta 1 Orionis C. This star is a giant star with a temperature of approximately 40,000 Kelvin, emitting stellar winds and intense radiation pressure that affect the surrounding gas and dust clouds. These interactions play a significant role in shaping and evolving the gas and dust within the nebula. In conclusion, the Horsehead Nebula serves as an excellent laboratory for understanding the processes of star formation and investigating the evolution of the universe. This captivating structure can be further examined and understood through observations made with next-generation observatories and space telescopes. This provides an exciting research area for astronomers and offers a deeper understanding of the nature of the universe. Regions of star formation, like the Horsehead Nebula, play a critical role in understanding the complex and dynamic nature of the universe. These nebulae initiate the birth of stars through the condensation of gas and dust clouds while undergoing continuous change and evolution within themselves. Star formation regions assist astronomers in comprehending the processes of star formation, the birth of stars, and the evolution of surrounding materials in the cosmos. The condensation of gas and dust clouds within the Horsehead Nebula occurs as they come together under the influence of gravity, leading to large-scale collapses. During these collapses, chemical compounds such as molecular hydrogen, H2, carbon monoxide, CO, and molecular oxygen, O2, within them condense and trigger the birth of new stars. This process is a result of various interactions including magnetic fields, thermal radiation, and radioactive decay. In star formation regions, dense gas and dust clouds not only influence the birth of stars, but also the distribution and evolution of the materials surrounding them. Particularly, these regions frequently witness intense stellar winds, high-energy radiation events, and supernova explosions. These events alter the shape and distribution of surrounding gas and dust clouds, thus affecting the evolution of the nebula. The constant evolution within star formation regions like the Horsehead Nebula makes them a significant subject of research for astronomers. Understanding the evolution of these regions is crucial for comprehending the processes of star formation occurring in the universe and the overall evolution of the cosmos. With advanced space telescopes and ground-based observatories, the internal structure and evolution of star formation regions can be examined and understood in greater detail. In particular, next-generation telescopes like the James Webb Space Telescope have the capability to conduct high-resolution observations in infrared wavelengths. These telescopes enable us to examine the internal structure of star formation regions in more detail and aid in a better understanding of the processes of star formation. Consequently, star formation regions like the Horsehead Nebula play a critical role in comprehending the complex processes occurring in the universe and enable astronomers to delve deeper into the nature of the cosmos. Therefore, detailed studies of such nebulae are indispensable for research in the field of astronomy. Molecular clouds like the Horsehead Nebula are one of the dazzling riches of the universe and serve as critical laboratories for the processes of star formation. These clouds typically form as dense gas and dust clouds come together under the influence of gravity, harboring the birth of new stars within them. However, these immense structures not only give birth to stars, but also shape the evolution and life cycles of the universe. The birth of a cloud often begins with the gravitational collapse of a dense gas and dust cloud within a molecular cloud. This collapse leads to the condensation and aggregation of compounds such as molecular hydrogen, H2, carbon monoxide, CO, and molecular oxygen, O2. The condensation process can sometimes be triggered by external influences or the effects of nearby stars. Newly born stars influence the surrounding gas and dust clouds, causing the dispersal of this nebulous material. Young stars, in particular, undergo high-energy events such as stellar winds and supernova explosions, which contribute to the dispersal and evolution of surrounding material. The evolution of molecular clouds like the Horsehead Nebula is shaped by a complex interaction of various factors and processes. These include gravitational collapses, magnetic fields, thermal radiation, stellar winds, and supernova explosions. These interactions influence the internal structure, distribution, and evolution of the nebula. Unfortunately, the lifespan of these magnificent entities is limited. According to NASA's data, clouds disperse and dissipate over time. The Horsehead Nebula is estimated to disintegrate within the next 5 million years. Therefore, astronomers strive to better understand the evolution and life cycles of such clouds. In conclusion, molecular clouds like the Horsehead Nebula are significant components of the complex processes and evolution occurring in the universe. The study of these clouds is crucial for understanding the processes of star formation and tracking the evolution of the universe. These studies enable astronomers to gain a deeper understanding of the nature of the universe and help humanity better grasp its place in the grand scheme of the cosmos. The latest NASA images provide a highly valuable resource that is significantly advancing scientists' understanding of the complex structure and internal dynamics of the Horsehead Nebula. These results not only contribute to a better understanding of the nature and evolution of molecular clouds, but also help us grasp the fundamentals of the processes of star formation in greater depth. The details revealed in the images offer researchers the opportunity to closely examine and analyze the structures and formations within the nebula. Particularly, the shape, density, and distribution of gas and dust clouds provide crucial clues about the conditions under which star formation processes occur and how they evolve. These details contribute to understanding a range of complex physical processes, from gravitational collapses triggering the birth of stars to the influence of magnetic fields. Furthermore, the movement and transformation of materials within the nebula aid in understanding the dynamics and evolution of star formation regions. The movement of gas and dust clouds is a result of both environmental interactions and internal physical processes, which in turn affect the overall evolution of the nebula. Therefore, understanding these dynamics contributes to a broader understanding of star formation processes. However, further analysis and research are needed to fully interpret and understand the data provided by these images. This, along with future observations and theoretical studies, will help us to understand the nature of the Horsehead Nebula and similar structures more comprehensively. This, in turn, will enhance our knowledge of the nature of the universe, contributing to advancements and discoveries in the fields of astronomy and astrophysics. In conclusion, the new NASA images offer an opportunity to examine the complex structure and internal dynamics of the Horsehead Nebula, thereby contributing to a deeper understanding of the nature of the universe. These data not only assist scientists in understanding the processes of star formation and the evolution of molecular clouds, but also provide insights into the overall evolution of the universe. This opens up avenues for scientific progress and exploration in astronomy, aiding humanity in better understanding the mysteries of the universe. The new NASA images provide a detailed opportunity to examine the internal dynamics and evolution of dust clouds within the Horsehead Nebula. These images allow for a clear observation of how dust clouds evaporate and how dust particles and heated gases are swept away. Additionally, we can understand in more detail how dust obstructs and disperses light. The evaporation of dust clouds is generally triggered by the intense radiation or stellar winds from nearby stars. During this process, dust particles and gases are heated and evaporate, being swept outward from the nebula. These observations help us understand the dynamics and evolution of the internal structure of the nebula, while also allowing for a better understanding of the processes of star formation. Observing how dust clouds obstruct and scatter light provides important information about the density and distribution of matter within the nebula. These findings indicate the significant role that dust clouds play, making it challenging to observe the structures and formations within the nebula. The light-obstructing and scattering properties of dust are considered critical indicators for understanding the internal dynamics and processes within the nebula. Such observations assist astronomers in better understanding the evolution of molecular clouds and the processes of star formation. Additionally, understanding the interactions and evolution of dust clouds within the nebula helps us better understand the formation of new stars and planets in the universe. In conclusion, these types of observations help us better understand the complex nature of the universe while also opening up scientific research and discoveries in the field of astronomy. Observing the dynamics and internal structure of dust clouds advances scientific progress in astronomy and helps us better understand the mysteries of the universe. This magnificent discovery further enhances our passion to unravel the infinite mysteries of the universe and encourages us to delve deeper into the exciting world of science. Space is like an endless labyrinth that fuels humanity's curiosity and thirst for exploration, and each new finding motivates us to delve deeper and ask more complex questions. In this journey of discovery, each of our contributions is important. Coming together as scientists, researchers, observers, and enthusiasts, we must continue to work together to illuminate the mysteries of the universe. With future observations, discoveries, and studies, we will continue to venture further into the depths of space, expanding our knowledge and better understanding the nature of the cosmos. This is not just about scientific advancements, but also an expression of humanity's desire to explore. Wishing you days filled with science, and together, let us continue to push the boundaries of knowledge, advancing towards greater understanding and enlightenment.